All right, let's set the scene. Imagine we're about to pull off a heist. But we're not cracking into a bank vault for gold or jewels. Nope. We're going after something way more valuable in today's world. The secret data that's locked deep inside an AI.
So let me ask you something a little unsettling. Could an AI be tricked into giving up a picture of your face if all someone had was your name? I know, it sounds like a plot from a sci-fi thriller, right? But this isn't fiction. It's the exact question a group of researchers set out to answer.
So, you're probably wondering, how is that even possible? Well, to get how the heist works, first we have to understand the vault. And in the world of AI, the vault is often what we call a black box model.
Okay, so a ton of companies today use these services called Machine Learning as a Service, or MLAS. Think of it like this. A company takes its sensitive data, we're talking medical records or maybe even employee headshots for new security system, and they upload it to a cloud platform. That platform then does all the heavy lifting and builds a super powerful custom AI just for them. And they can use it through a pretty simple programming interface, an API.
So now, the company can ask this AI for useful predictions, like confirming, yep, that's Sarah from accounting at a security gate. But here's the thing. The AI is a complete black box. The company that owns the data can't even see how it works inside. And all that sensitive training data, it's supposed to be locked away, totally secure inside that vault. But is it really?
And that brings us to the mission. Forget brute force. We're not taking a sledgehammer to this vault. This is a subtle, clever heist, one that actually turns the AI's own logic against itself. It has a name, and it's called a model inversion attack.
So instead of kicking down the front door, a model inversion attack is more like charming the security guard. It's all about asking the AI a bunch of really specific, carefully crafted questions to slowly but surely piece together the secrets it's designed to protect.
Every good heist has a plan, right? Here's the 4-step playbook. Step 1, you pick your target. Let's say a public facial recognition model. Step 2, you get your hands on just one tiny piece of information that's already out there, like someone's name. Step 3, this is the clever part. You start poking the model with very specific queries. It's kind of like playing a game of hot or cold. And finally, step 4. You take all the AI's responses and use them to put the puzzle together and reconstruct that secret data.
See, every vault has a weak spot. And for these AI models, the flaw isn't some bug in the code or a weak password. It's something much more subtle. Think of a safecracker listening for the click of the tumblers. The AI has its own version of that click. It all comes down to something called a confidence score.
Right. So when an AI makes a prediction, it doesn't just say, that's Alice. It says, that's Alice, and I'm 99% confident. And that is the key the attacker uses. They start feeding the AI basically random noise, but they tweak it little by little, and they watch that confidence score. And when they see that number jump up, bingo. That's the click. It's like the safecracker hearing one of those tumblers fall perfectly into place. And hey, don't just take my word for it. This isn't just some abstract theory. The researchers who discovered this, Fredrickson, Jaw, and Ristenpart, they said it themselves. They wrote, and I'm quoting here, "The key enabling insight is that we can build attack algorithms that exploit confidence values exposed by the APIs. In other words, those little confidence numbers are the keys to the kingdom."
Okay, so this brings us to the main event, the climax of our story. The researchers decided to put this theory into practice with a real-world case file, stealing a face right out of a facial recognition model. So the mission was crystal clear. Armed with nothing more than a person's name and public access to the AI, could they actually use this confidence score trick to digitally reconstruct a recognizable image of that person's face? And here it is. This is the result. On the left, that's the face the AI was tricked into creating from scratch. And on the right, that is the actual photo of the person from the secret training data. I mean, look at that. It's not a pixel-perfect copy, sure, but it's unmistakably the same person. The heist was a total success.
But just how successful are we talking? Well, the researchers showed this reconstructed face to human volunteers, and a staggering 80% of them could correctly identify the real person from it. 80%. That is an absolutely massive success rate for an attack that started with literally nothing but a name.
Okay, so this is obviously more than just a cool, clever hack. This has some serious real-world consequences for every single one of us and our data privacy.
So, who's really at risk here? The research paper is really clear on this. If your data, whether it's your face, your medical information, whatever, was part of that initial training set for an AI, then you are at a way higher risk from these kinds of attacks than someone whose data was never in there to begin with.
All right, so how do we stop the heist, right? How do we make the vault more secure? Well, the researchers also looked into that, and they tested a surprisingly simple but really effective countermeasure. What if you just made the AI a little less precise, a little less chatty? Remember that confidence score, that click our safecracker was listening for? It turns out you can pretty much secure the whole vault just by rounding that number. So instead of the AI reporting back that it's, 99.23% confident, it just says it's about 99% confident. That tiny little change adds just enough static, enough noise to the signal that the attacker's whole method just stops working. The reconstructed image becomes useless and the private data stays safe. And this all leaves us with a really big, critical question for our future. This whole attack works by exploiting how an AI communicates how certain it is. So as these AI systems get woven deeper and deeper into our daily lives, making decisions about our health, our money, our personal security, the real challenge isn't just about making them smarter, it's about making sure that in their quest for intelligence, they don't end up betraying the very secrets we've trusted them to protect.